Good evening, everyone. So today we are here to address the interview preparation session for data science. Today's topic is data science. So let us take the first question. Okay. So let us take the first question. What is data science? So what is data science? So we can, in some simple terms, we can say it is a field in computer science that explicitly deals with turning data into information and extract meaningful insights from it. In simple terms, we can say that. So let us go to the next question. Yeah, sorry for that. Let us go to the next question. So why is data science so popular? Why is it so popular? Okay. Is it okay? Yeah. So is the screen size okay? Yeah, okay. So why is it so popular? So we know that data science is a, yeah, more. Yeah. So it is so popular because of the insights we draw from it, and it helps us in majorly we can say it helps us in decision making. So it allows us to draw insights from raw data, and these insights have led to some major innovations in several products and companies. So yeah. So due to this decision making, we have some very good innovations in several fields. So also using these insights, we are able to determine the taste of a customer, and according to the tastes of customer, we are designing the products also. So it is a very important thing for companies. So let us go to the next question. So next question may be like, how is it different from, how is DS, how is DS different from other traditional programming languages? Programming language. So in traditional programming languages, we used to analyze the data, means analyze the input, then figure out the expected output, and then write the code. Means we had to make write the rules for the input to go through to get the expected output. But in data science, what we do is we have a large volume of data that already contains the necessary input and output. We just we just map inputs to outputs, and this mapping is yeah. So we use algorithms which maps the input data to the output data, and this mapping is nothing but the model preparation. So this process of it generates, we can say the model is the rules which generates, and this process of rule generation is also known as training. Yeah. So we can say that yes. So we can say that traditional was input, sorry for the bad handwriting, plus rules gives us output for traditional. But in case of data science, we have an input, we had an input, and we also have the output, and it gives us the rules. It has some predefined algorithms which maps the input to output, giving us the model. We can use this model for uh, predicting the uh, output in the new data. So let's come to next question. What is machine learning? So what is machine learning? So we can say it is a subfield of data science that deals with existing data to help systems automatically learn new skills. Means it is same as data science. Only it is a subfield of data science. Here we have predefined algorithms which learns, means which maps the rules from input to output, and we can use these rules, which is also called as models, to get output on the new data. Yeah, we can say also say a subset of AI. Actually, all are the subset of AI. Everything in data science means AI is the superset. So next question, what is deep learning? Everything works on algorithms only. We have we actually don't write any algorithms. We use the predefined algorithms only. Yeah. So right. Deep learning is a subset of ML, correct? It is a field in ML that deals with building of ML models using algorithms that try to imitate the process of a human brain. It tries to mimic the human brain and uses it. Yeah, yeah, it is a type of. Yeah. So we use this deep learning in case of neural networks. We use this to deploy deeply connected neural networks. So next, coming to statistics a little bit. What is a confusion matrix? So what is a confusion matrix? So we can say confusion matrix is nothing but a table that is used to estimate the performance of a model. So let me draw it. Okay, so we have predicted value here and actual values here. The predicted value, this is positive, this is negative. For actual values, this is positive, this is negative. So what we get here is, here we get true positives, here we get false positive, here we get false negatives, here we true negatives. So what is this? So if we have a model and we are checking for the confusion matrix, so model has some actual values, and by the process of modeling we have found out some predicted values. So then we check in a confusion matrix the accuracy of the model. So we see here, if predicted value is positive and also actual value is positive, we get true positives. Means the true positives. Yeah. So the true positive values are the values which have been predicted as true, and also in actually they are true. Likewise, if we get false positive, these are the values which are predicted true but are actually not true. Likewise, we have false negative. These are the values which are predicted false but are actually true. Then we have true negatives, which are predicted as false but are actually true. So what can we find from this matrix? Let's go to the next question. So what are the different evaluation measures of the confusion matrix? What are the evaluation measures of a confusion matrix? So we have many evaluation measures for confusion matrix. We'll be discussing some of those. First one is error rate. Error rate. So what is error rate? Error rate is okay. So error rate is nothing but it is the number of all incorrect predictions by total number of predictions. That means by total number of data. Means total data. So it is number of incorrect predictions divided by total number of data. So if we see from the confusion matrix, I should have left the confusion matrix. Data predicted okay. So the formula of error rate is false positive plus false negative divided by all the data means true positive plus true negative plus false positive plus false. So this is the formula for error. Then what is accuracy? How can you find the accuracy from a confusion matrix? So it is the number of correct predictions divided by total number of data. Yeah, right. So PP plus 2n divided by this. So then we come to other measures like sensitivity. Sensitivity. So what is sensitivity? Sensitivity is also called as recall or true positive rate. So what is sensitivity? So sensitivity is total number of correct positives. Total number of correct positives divided by total number of positives. Yeah, right. So we get the formula Tp by Tp plus Tn. Sorry, false negative. Fn. Yeah, right. So what is next is specificity. Specificity. What is specificity? It is also called as true negative rate. It is just the opposite of that. It is total number of correct negative prediction. Total number of correct negative prediction by total number of negatives. So here we have the formula Pn divided by En plus false positive. Next we come to precision. So what is precision? It is also called as positive prediction value. Positive prediction value. So what is precision? It is the number of correct positive predictions by total number of positive predictions. Number of correct positive predictions by total number of positive predictions. Total positive. So formula is TP by TP plus. Then we have another false positive loop. What is false positive loop? So it is number of incorrect positives by total number of negatives. You can write it as FP by Tn plus FP. Okay, that's some sort of confusion matrix. Now let us go to what are the different types of learning methods. What are the different types of learning methods in machine learning? So what are the different types of learning methods in machine learning? So we have three learning methods: supervised, unsupervised, and reinforcement learning. So what happens in supervised, what happens in unsupervised, what happens in reinforcement? So supervised, we can say simply generates formula based on input output, means it maps input values to output values by process of modeling. Means we create a model using the default algorithms and map input data to the output values. In unsupervised, we find the relation or association, we can say, between the input values and group them. In reinforcement learning, we make an environment and we put an agent inside that, and the agent learns from in the environment and is rewarded accordingly. So what are the types of problem? Question is, what are different types of supervised learning? What are the different types of supervised learning? So in this case, we have two types of supervised learning, namely classification and regression. So what classification does is it predicts the discrete values from the data given. It gives discrete output In regression, we get the output as a continuous data. So some of the examples of classification in some of the algorithms used in classification are naive bias, support vector machines, logistic regression. Likewise, in regression, we use linear regression, multinomial regression, non-linear regression, and many others. So next question is, what is unsupervised learning? And what are the different methods used, algorithms? What are the different algorithms used in unsupervised learning? Unsupervised and algorithm used. So what is unsupervised learning? So in unsupervised learning, we don't have labeled data set. There is in supervised learning, we generally use labeled data set. So unsupervised learning, we can say, yeah, unsupervised learning, we can say, is a self-organizing learning method. What it does is it explores the underlying patterns in the data and groups the data according to the similar patterns. So some of the algorithms used for unsupervised learning, we can say hierarchical clustering, k-means clustering. Then we have neural networks CNN, RNN, ANN. Then also we have principal component analysis for dimension reduction. Yeah, correct. So next coming to what is reinforcement learning. So what is reinforcement learning? Yeah. So here the algorithms learn to react from environment on their own. So we place a learning agent and there is always a start and end state. The aim of the agent is to reach the end state from the start state. So what it does, the agent tries to manipulate the environment and every time it succeeds, it gets a reward, and on failure, no reward is given. This is called positive reinforcement learning. Then he gets a reward. Also, there is negative reinforcement learning in which we punish the learning agent, if he fails. So, what are the examples of reinforcement learning? Yeah, gaming theory. Mainly it is used for gaming. Yeah. So we learned about supervised, unsupervised, and reinforcement learning. So let us see what are the difference between them. So I have prepared a table. So we see here, supervised learning, it uses labeled data. Unsupervised learning doesn't use labeled data, it uses unlabeled data. And reinforcement learning doesn't have a data, it interacts with the environment. So what are the types of problems we can uh, use supervised, unsupervised, and reinforcement. We can use supervised for regression, classification, unsupervised for association and clustering. These are not just only examples, there are many others. Uh, Reinforcement machine learning is used for exploitation or exploration. Then type of supervision required. Supervised machine learning requires supervision. Unsupervised machine learning doesn't require any supervision. Also, reinforcement doesn't require any supervision. So, what are the algorithms used? In supervised, we use linear, logistic, SVM, KNN. Unsupervised, K means, C means a priori. And for reinforcement learning, we use Q learning, SARSA. So, what is the main aim of this learning? So, supervised learning aims to calculate the outcomes. Means we first train the data, and using the training model, we find out, predict the outcomes of the new data. So, its aim is to calculate outputs. In unsupervised machine learning, it discovers the underlying patterns and groups accordingly. For reinforcement learning, the learning agent learns a series of action and uses this learning to solve the problems. So where can these be used? So supervised learning is used in risk evaluation and forecasting sales. Unsupervised learning is used in recommendation system, anomaly detection. And for reinforcement learning, it is used in self-driving cars, which is now upcoming future, I think. And then in gaming and also in healthcare. So coming to the next question. So yesterday we learned about Python. So what are the different popular libraries? What are the popular libraries? Used for data science? Yes, correct. So we will be discussing some of them. So first is TensorFlow. What is TensorFlow? Why is this library used? So TensorFlow is used mainly for deep learning applications. Okay. Then we have NumPy. all must be knowing what NumPy is used for. So NumPy actually, NumPy is used for mathematical and scientific computations basically. It is the fundamental library for mathematical and scientific calculation. Fundamental library for scientific computing. Then we have SciPy. So what is SciPy used for? We haven't got yet to pandas, but yeah, it is right. So SciPy is basically used for complex math, complex mathematics, science problems, science and engineering problems. Okay, next coming to matplotlib. What is matplotlib used for? It is used for creating static, animated, and interactive data visualization. Used for data visualization. Then we have pandas, which we have already written the chat. So it is used for create. Generally, we can say it is used for data manipulation. Then we have keras. What is keras used for? Yeah, pandas is used for creative forms, right? So what keras does is it provides an interface for TensorFlow. Provides an interface for TensorFlow, so we can have fast, so that fast implementation can be done on deep neural networks. So coming to the end, we have an SK learn. It contains all the algorithms for classification, regression, and clustering. So these are some of the popular libraries of used in data science. So we'll have to end here today, and tomorrow we'll be going a little deep inside machine learning. So thank you.